Hello, and welcome to this lesson on the melting and boiling points of small molecules. In today's lesson, we will understand that molecular substances tend to have low melting and boiling points. We will then explain these properties in terms of intermolecular forces. This lesson will help us make connections between the microscopic interactions within molecules and their macroscopic properties, enriching our broader comprehension of chemical behavior. Substances that are made up of small molecules such as oxygen, nitrogen, chlorine, water, and ethanol often exist as gases or liquids at room temperature. They have low melting and boiling points when compared to metals or giant covalent structures like diamond or silicon dioxide. But why is this the case? To understand this, we need to distinguish between two types of forces. First, covalent bonds. These are the strong bonds that hold atoms together within a molecule. For instance, in a water molecule, the hydrogen atoms are covalently bonded to the oxygen atom. The second type is intermolecular forces. These are the forces that exist between the molecules themselves. In small molecular substances, the forces holding the molecules together are much weaker compared to the strong covalent bonds within the molecules. It is those intermolecular forces that are broken when molecular substances melt. The covalent bonds do not break during change of state. For example, if we consider ice, water, and steam, you can see that the bonds between hydrogen and oxygen atoms, shown in red in the diagram, remain the same. It's the green forces between molecules that are affected. The strength of intermolecular forces in a substance determines its melting and boiling points. In small molecular substances, the intermolecular forces are weak, so it doesn't take much energy in the form of heat to overcome these forces. As a result, they have low melting and boiling points, as relatively little energy is needed to break the forces and change the substance's state. For instance, oxygen is a diatomic molecule with weak intermolecular forces, resulting in a melting point of minus 218.8 degrees Celsius and a boiling point of minus 183 degrees Celsius. This means it is a gas at room temperature. Similarly, nitrogen, another diatomic molecule, has a melting point of minus 210 degrees Celsius and a boiling point of minus 195.8 degrees Celsius, making it a gas at room temperature as well. Ethanol, a small molecular substance, has a melting point of minus 114.1 degrees Celsius and a boiling point of 78.37 degrees Celsius, which is why it is a liquid at room temperature. You may have noticed that while ethanol's boiling and melting points are relatively low, they are a bit higher than oxygen's and nitrogen's. That is because generally the bigger the molecule, the stronger the intermolecular forces. These stronger intermolecular forces result in higher melting and boiling points compared to smaller molecules. A great example of this is glucose, which has a melting point of 146 degrees, which is higher than the melting points of many smaller molecular substances. By understanding these concepts, you'll be able to predict and explain the physical state and behavior of molecular substances based on the nature and strength of their intermolecular forces. In today's lesson, we delved into the properties of small molecular substances, particularly focusing on their low melting and boiling points. We distinguished between covalent bonds and intermolecular forces, and understood that it is the weak intermolecular forces in small molecular substances that result in low melting and boiling points. Since these forces require less energy to overcome, these substances easily transition from solid to liquid and liquid to gas at relatively low temperatures. This foundational knowledge will help us predict and explain the properties and behaviors of various molecular substances.